All right, for question 4, or example 4, if you're struggling with it a little bit, don't stress too much because you don't actually need to know the distance formula for this test, but there are some practical applications for this problem. So, if it says, find the points on the curve y is equal to x squared that are closest to the point of 0 and 3. So, if I was to graph this out, then I'm going to have a quadratic, y is equal to x squared. I'm going to have the point of 0 and 3. And I want to know what the closest point is connecting 0 and 3 to that y is equal to x squared. Now, because we know it is symmetrical and it says the points, we know that it could be the positive or the negative version of this. Because it's symmetrical, it should be the same distance. So we're going to say that we're going to let x and y represent the unknown points. And we're going to let d represent the distance. So, with the distance formula, distance is equal to the square root of the change in y squared plus the change in x squared, because it's going to be the hypotenuse of that right triangle that is created. Well, we also know that y is equal to x squared, and we know a point that we're going to, the 0 and 3, which means that we're going to rewrite this as d is equal to y2 is going to become x squared, y1 is 3, x2 is still just going to be x, and x1 is 0, given the point that we're coming from, which means that d is going to equal the square root of x squared minus 3 squared plus x squared, or the square root of x squared minus 6x got to square this up properly, x to the 4 minus 6x squared plus 9 plus x squared, which means that this is going to equal the square root of x to the 4 minus 5x squared plus 9, or x to the 4 minus 5x squared plus 9 all to the power of 1/2. We're going to take that and we're going to derive it, which means that d prime of x is going to equal, let's do it with a little more space, d prime of x is going to equal 1/2 x to the 4 minus 5x squared plus 9 to the power of negative 1/2 multiplied by 4x to the 3 minus 10x. Well, the times 2, or times 1/2, and the common factor of 2 that I'm going to pull out of here will simplify this. And I'm going to wind up with x to the 4 minus 5x squared plus 9 to the power of negative 1/2 and 2x cubed minus 5x. Well, I can also pull out a common factor of x from here, and I'm going to move that negative exponent down. So I'm going to get x and 2x squared minus 5 in the numerator, and I'm going to have the square root of x to the 4 minus 5x squared plus 9 in my denominator. Then I'm going to go to my critical numbers. Well, I have a numerator and the denominator, so I'm going to take the numerator and I'm going to say that from the numerator, I'm going to have x equals 0. I'm going to have 2x squared minus 5 is equal to 0, which means that 2x squared is going to equal 5, or x is going to equal the positive or negative square root of 5 over 2. For my denominator, I'm going to have if the square root of x to the 4 minus 5x squared plus 9 is equal to 0, then x to the 4 minus 5x squared plus 9 is equal to 0, which is not possible. Fun stuff. Then I'm going to go to 7. I'm going to do my first derivative test. The negative square root of 5 over 2 is 0, and the square root of 5 over 2. When I take my d prime of x, I get a negative, a positive, a negative, and a positive, which means that my d of x is going to be decreasing, increasing, decreasing, and increasing. And look what we have here. We have a minimum, and we have a maximum. Well, when it says closest, close is just a fancy way of saying minimum, which means that, therefore, square root of 5 over 2 and 5 over 2 and the negative square root of 5 over 2 and 5 over 2 are the points closest 2, 0, and 3 on the curve y is equal to x squared. Once again, if you're struggling with this one, don't stress too much.